Actually, no. Wow. Okay. Entonces, 2 times A, que A es 2, and B es 4, cosine C. Y C es 115 degrees. Okay, super. C squared is equal 20. 20 is 4 plus 16. Minus something. Minus 16. It's a 4 times 4, 16. Cosine 115 degrees. Entonces, in that moment, of course, we use the calculator, ¿no? Okay, entonces C squared is equal to 26.76. So you compute that part. This is expression in the calculator. And finally, C is square root this number. Okay, it's approximately 5.17. Okay, 5.17. Now ready to apply now the law of sine. Why not? I have the only angle I have in my hand is 117 divided by C that I have now is equal sine, for example, A or B, either way, divided by 2. Okay. Or you can use sine of B divided by 4. But in my paper using A. The sine of A cross multiply is equal to 2 times sine 115 degrees divided by 5.17. And the answer is 0.35. And the angle A is sine inverse. 0.35. Okay, is 20.5 degrees. Okay, entonces angle B is pretty easy. Angle B is 180 minus 115 minus 20.5. And the answer is 44.5 degrees. Bone, bone, and bone. 3 answers we need. Super, super easy. Everyone follow me?
Yes, Professor. So it means, like, Professor, when we have SIS, it means that we need to apply the law of cosine of the sine.
Yes.
Sorry. Okay.
Yes. That definitely. When you have Genuela, side, and side angle side, law of cosine. And when you have two angles on one side, it doesn't matter the other. Law of sine. And when you have the most complicated, ambiguous, two sides and one angle, and the angle is not exactly in between the side, you apply the law of sine again. But you need to consider two possibilities. When you apply sine inverse, you consider two possibilities. This is the quick review about the only thing you need to memorize to face any problem of this. Okay?
Okay, Professor, thank you. Can I take a picture? Okay, thank you, Professor.
Okay. The rest is easy. Very easy. For example, 13, 14, and 15 is about area. Formula area. Entonces es, just plugging in the formula and that's it. The formula, the famous formula for the area is 1/2 multiplication to side. For example, A times B sine the angle in between this and this. In this case, the information gets given is this side, que es 1 and 9. Look, 1 and 9. The area is 1/2 multiplication 1 times 9 times sine of this angle, que es C, ¿no? Que es 150 degrees. Put in the calculator, and that's it. The answer, it was 4.08. So 4.08. Es obvio que this is area. Area is surface, and surface is the area enclosed, ¿no? For the triangle. Entonces, the unit of this, depending the unit is given the side, que es, suppose que es feet, entonces es square feet. Si suppose es inch, es square inch. Suppose que es meter, square meter. Es area. Clear?
Yes.
Okay. We have now 14 is similar. Area is equal multiplication. When you have two sides and the angle in between the side, you're using that formula. 1/2 multiplication by 3 multiplication by 6 multiplication by sine 25 degrees. Boom. 18, 9. 9 times sine 25 degrees. Put in the calculator, and the area is equal 3.8. Boom. Any question?
No questions, Professor. So it means like we just need to put the formula. That's it. When
Yeah.
we okay.
But you need to be careful. Okay, you have the information, the properly information gets two sides and the angle in between. Suppose you have another sine, another size, and no angle in between, so you cannot apply the formula, no?
Yes.
Be careful. Well, no, 15 is different because you have no information about the angle. Entonces, okay. We can apply. You can consider like a side. You solve them by the law of cosine, and you find at least one angle, and that's it. It's a one possibility. However, I want you practice using the Heron formula. The Heron formula say area is square root s minus a, x minus b, and x minus c. Now, what is s? S is equal a plus b plus c divided by 3. By 3, no, by 2. By 2. Okay. Entonces you have the side, que es a, 4, and 5. Entonces you adding 4, 8, and 5 divided by 2. This is s. Is 17 over 2. Okay, it's 8.5, no? 17, 8.5. 8.5 in fraction and decimal. Either way, now plugging in square root 17 over 2 is s multiplication by 17 over 2 minus 8. Because a is 8. 17 over 2 minus b is 4. And 17 over 2 minus 5. It's complicated, no? But you put in a calculator and that's it. And the answer is 8.18. It's the area. 8.18, option D. Clear?
Yes. So, Professor, we just didn't that. We just used a different formula because it doesn't have the angle, right?
Okay, when you have only information about size and no angle, you can apply this formula, Heron formula. And it doesn't matter que the hour triangle is right or obtuse or acute. The formula is always general. Okay, not bad. Let's move to the next page. I can erase or no?
You can, Professor.
Okay. There you go. Well, 16 is similar. 16 is similar. 16 is hero formula again. Because you have the side is 9, 9, and 7. Okay, so you apply S. S is equal 9 plus 9 plus 7 divided by 2. 25 over 2 is 12.5. The student can prefer decimal, you convert to decimal, the answer doesn't change. And now finally substitution in the formula. The formula is 25 over 2, parenthesis, 25 over 2, minus 9, times 25 over 2, minus 9, repetition because you have two sides equal, and 25 over 2 minus 7. This is 12.5. It's important that this quantity can have no physical meaning or geometric meaning. No, I don't know what is that. It's bigger than every side, no? Si es smaller, entonces one subtraction is negative, entonces have no sense. Pero no, for sure. Ese sum divided by 2 it's no average, because average divided by 3. Entonces it's bigger than average. You know, it's the beauty of mathematics. And the answer is, put in the calculator, is 29.02. There you go. Bam. Clear?
Yes.
Okay. No, but okay, let's move on to the. Okay, and the test, I promise. Okay, put one question like that. Again, super easy. It's elementary, straightforward. It's the harmonic motion. Harmonic motion, you know, is the motion que is, you know, remember, sine or cosine. Remember que to talking about cosine or sine, depending only what the different cosine and sine. Sine graphic start in 0. It's oscillating. Suppose we have the famous spring and the mass. You stretch and release and start the motion. Okay, hypothetically, this motion continues forever. See, there are no power loss. So the energy is conserved. The energy is transferred from the mass. Okay, the mass have kinetic energy to a spring que has potential elastic energy. Now this is sine. This is sine. And cosine, no. Cosine is, suppose que you stretch in any direction and release. This is cosine. You see cosine and sine is almost the same function, but you have phase shift 90 degrees. But the problem say que amplitude is 8. Amplitude is this. And this is negative 8, no? And the object attached to the coiled spring is pulled down. See, it's down is negative, right? It's negative. So the answer is negative cosine. Right? Makes sense, right? Makes sense? This is super elementary. Don't try to see a secret here. A super elementary question. So this is, okay. Sine is impossible because sine starts 0. No, you stretch the spring and release. Pero the keyword is down. Pull it down. Si es down, es negative. Es negative cosine. Ahora, what is the problem? The problem is que the period is given. Period is 4 seconds. And you need to know that the period, they call in physics no P. No, they call T in physics. Okay. The problem is not the letters, the concept behind this. A 4 seconds. And that means the time of the one cycle. So one cycle means one oscillation. Suppose case like that. So my function start in negative A. Let me use another color. And release. Go to the equilibrium position. Now positive A. Now 0 again. Go to the negative A. And you complete one cycle. One cycle is one cycle. When the one oscillator go to the one, arbitrary position to the return to the same position. I take like a reference position, the amplitude negative. But it doesn't matter from 0 to 0, for example, from 0 to another 0, no, this is the same cycle, the same direction, the same interval of the time. This is, in our problem, is 4 seconds. And the mathematical formula to find omega is 2 pi over period. It's a classical formula in the physics, in the harmonic motion, weight. Entonces, basically, omega is the angular frequency, is 2 pi over 4. Reducing lowest term is pi over 2. Entonces, the formula for the hour harmonic motion in the question 17 is negative 8 cosine 1/2 pi t. Okay, the formula in general is amplitude, sine or cosine, depending on the initial condition, cosine, and you put it here omega. Omega is a Greek letter omega, and the formula for omega is 2 pi t. It's an angular frequency. Omega in our example is pi over 2, plugging in pi over 2, either way, pi over 2 here, pi over 2. Not necessarily in that way, pi over 2. T. So in my opinion, is the option B, no? Makes sense, right? This is the formula for what? What is that? Displacement of the object, no? Of the system formed by spring and mass. Do you understand the basic idea or no?
I didn't understand, Professor. Why is it cosine?
Good question. Okay, suppose we have a spring. And the mass. And this is the equilibrium position. What means equilibrium position? Because if I don't apply anything, the system formed by spring and mass stays the same. It stays the same. Doesn't move, no? However, the problem says I pull it down. So I stretch in the spring. And this is my mass. In this moment, the displacement, the original is A pero down. Okay, I suppose it's negative. And release. And the motion que described here is something like that. Es obvio que es cosine. Yes or no, Noela?
Yes, Professor. I understood now. Thank you.
And it's negative because the keyword and the problem say que es negative. See, I suppose que I am doing another condition. Que another condition is que I compress the spring over a unit. Entonces, my spring now is compressing. Okay, that distance is a unit. Suppose it's not the same, but sorry. Entonces, my spring oscillated like that. Entonces, the formula is positive A, not negative A. Okay? And what another possibility? I never resign, Professor. Never resign. Yes, it's possible to be signed when you, for example, no stretching, no compressing, but you touch, you apply some velocity to this. Suppose what you touch, pero too hard. Boom. Entonces you start the motion here, pero ya apply energy, mechanical energy, and you start here, oscillate. This is velocity. No stretching or no compressing. It's just boom, touch hard with the velocity. Entonces my oscillator is signed because it starts in position 0. But no, in this case, no, position negative or position positive. Make sense now? Super clear? Super clear. Super clear.
Professor, do you have another example that is like sine rather than it needs not cosine?
Well, no. This is the only example that exists. Okay, when you have no stretching, no compression, no, you touch the object. Okay, and automatically you introduce to the system energy, kinetic energy, and the system start motion, boom, 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 oscillator, but the initial position is 0 because I do not move down or over. No, I touch. That's it. Okay, so you have two kinds of the initial condition. This is physics. Initial condition. Conditions. Condition. I don't know. Condition of the position. So displacement in 0 equal -8 is down. Displacement in 0 is equal positive 8 is up. In that case, in both cases, the velocity at the beginning is 0. No velocity. Therefore, this is negative cosine. This is positive cosine. Another possibility is mathematically velocity initial is 10 meters per second and displacement in 0 is 0. I don't move. Velocity in 0 is -10 or negative whatever meter per second and displacement in 0 is 0. In this case, our system spring mass start in 0 displacement. Look, but we have enough energy to go over downward, depending the direction I touch with the energy. Make sense and more clear now?
Yes.
Okay, this is a quick review of physics. What do you think about the What do you think about the next question? Okay, it's very similar. No? Very similar. Next question. There you go. And the next question, the situation is similar. Is because it's the same problem with another informations. So amplitude 17. Of course, it's down because the problem say always common for the 17 and 18 is pulling down. And the period is 9 seconds. Okay, entonces I realize que es cosine, pero es negative cosine, es negative 17 cosine something. And here we have omega t. And omega is 2 pi over the period. It's 2 pi over 9. Now my final answer is displacement to any time is negative 17 cosine 2 pi over 90. In this case, es physics, guys. Entonces, our independent variable is no x, es t. Because of time. Okay. Makes sense, confusing, super confusing.
This one is easier than the other.
Yeah, it's my gift for the test. It's my gift. Okay, you see one question like that in the test. Now, finally, I want to show you curiosity. This is completely out of the test. Because in the test, I don't put something like that. It's the last question, que is the combination for the sine and cosine and the weight. Yes, non-sinusoidal, periodic, non-periodic, and the damping motion. Damping motion is interesting because in the real life, harmonic motion is totally ideal because there are no power loss of the mechanical energy. And the real life, no, we have power loss and the amplitude decreasing exponentially. Let me try to explain this. Something like that. Okay, something like that. Okay, this one. Okay, this is, displacement to any time is e to the minus t over 4 pi cosine t. Actually, I don't know if it's this answer or this answer because this is crazy. However, I do in Desmos to see. I put this equation in Desmos, and you see that. In the real life, in the test, we have no multiple choice. So I do the graph of this. Graph the damping vibration curve. Okay. What is vibration? Well, harmonic motion is like that. It's sine or cosine. In this case, cosine. Cosine. So cosine starting in this case, the amplitude is 1. Because we have no coefficients here, 1. Entonces, suppose que es like that. But this is ideal. When you have real, you have extra term que es exponential. And the exponential is something like that, decay. Decay in both directions. Because our exponential, our oscillation is a little bit, decreasing the amplitude, decreasing the amplitude, decreasing the amplitude. And the zero stays the same. But decreasing the amplitude. This is the idea. Let me show you in this. I create one script for you. Let's see.
So on the test, we need to graph that, or can we put it on the Desmos?
Yeah. Any, you see in the chapter 1, no? So there are no reason to do the graph in the piece of paper. Nowadays, no. Put in Desmos. The skill is now put correctly the expression and interpretation, the answer. That, okay? That this is the antique when I'm doing the graph in the piece of paper. No. Okay, let's move into the.
Test 3 that you sent is the exact same as the review that we're doing now.
No, exactly. It's
No.
similar.
Every question is the exact same.
In the test you say?
Yeah, the test is the exact same as the review that you're doing.
Okay, okay. Take advantage. I don't see that. Okay, no. Let me show you. So you pay attention, try to understand. Okay. Okay, this is Desmos. Do you see Desmos? Do you see or no?
Yes.
Okay. Question 19. I did that like that. This is the exponential, cosine. Of course, I put the restriction because I want the answer only on this positive x, no negative. I don't care negative. Look at that. Boom. Amplitude 1. And you see how actually my curve is the red one. No? And this is the bounded. Top and bottom. Positive or negative. You see how the amplitude decreasing until the object stop. Definitely. Clear?
Yes.
Okay, super. Now, the question 20 is about the superposition of different functions. Actually, is, let me see, in the original package, Sx minus sine 2x. Wow. We are doing now question 20. Question 20 is, look, is that function. Okay, for example, you can see, let me try to, y equal x only. Suppose y equal x only. It's a line, it's obvious. It's a line passing through the origin. Slope 1, nice. Beset the first and the third quadrant. Good. And the negative, let me copy another negative equal negative sine 2x is a sine. Double frequency because omega is 2 or b, whatever you want to call. So now the combination, the blue and the red, give me this one. Que es a sine, pero increase in the amplitude. This is non-periodic, of course, non-periodic, and non-sinusoidal. Okay? I don't know exactly in the option what is the, no, es you select the option que passing through 0, 0. Que I suppose que es the option D, no? The option D, I guess so. Do you see?
Yes, Professor, I have a question. The vertical intercept is 0 and 0, right?
Yeah. This is a glue to identification. Look at that. 0, 0. 0, 0. We have another point here, and another point here, que es 0 also. Es obvio que es the option D. Do you want I show you in the package or no? Or you see clear?
I can see clearly.
Okay. Now you see clear in Desmos. So the thing I try to explain is, do you want I show you in the package? For example.
Not really.
No? Okay, we come back. For example, we come back to the whiteboard, no? There you go. Do you see whiteboard now?
Yes.
I'm erase everything. I try to find the last page. No? PDF, MP3, boom, that one. Do you see it look like the option D, no?
Even the intercept.
Yeah. We have here, look, 0,0 of 0,0. Try, 0,0, and 2 intersect here and here. And here, no. We have y intercept 0,0 origin, but no another intercept. So no C. Of course, no A and no B. S, D. Make sense?
It does.
Excellent. Okay, guys. So now, in the rest of the time that we have, I want to introduce new chapter. Okay? New chapter. Not too much in detail because it's only spend the time doing that. Okay, this is the, remember this chapter is application again, but another kind of application. So in this chapter, in the last chapter, we study polar coordinate. Polar coordinate. Okay, normally the habit to do the graph in Desmos Es rectangular coordinate system, X and Y. For example, to find one specific point B, you determine the component X and the component Y, and you call X, Y. This is the tradition so far. Now we have a new way to express the coordinate. The new way is different. It's a little bit complicated to understand at the beginning. Look, the mathematicians define one point. Call it. It's similar to the planet and the Earth. We have North Pole and South Pole, right? I don't know si es North o es South, pero es Pole. Who making noise? Okay. Okay. And we have only one axis, this one. Okay, let's call it, I'm using the rule. Zero degree. Zero. We have one axis, okay, let's call it polar axis. Normally, I don't know why I put dotted line. This is polar axis. And that's it. And the rest is a family of the circumferences like that. A family of circumferences. Suppose one circumference is 1, radius 1, no? This is similar to say 1 here, 2, 3, 4, 5, no? Another circumference is 2, okay, the distance. Who is 1, who is 2? This distance. Radius 1, radius 2, it's a family of them. And you define, well, let me see, let me show you in detail actually the polar paper. Elegant polar paper. Elegant polar paper. Okay, let me try to find elegant polar paper. Polar. Where is the polar? I suppose que here. Polar. No, it's a picture. Sorry. It's a picture. But it's a picture in PowerPoint folder. Polar. Okay, there you go. It's a graph in polar. Look. Ooh.
Professor, do we need to print?
No. Don't worry for print. Nuela, because I want to show you, maybe not necessarily today, que I modify Desmos using polar, okay? No, you say polar, Desmo. Today we are working with the polar coordinate, and you press a button. Now the thing change. Now to define any point, for example, I have different example to show you. This is today is the intuitive idea to understand polar. No complicated, no conversion, no mathematics, only intuitive idea. Suppose I want to plot that point. 1, 5 pi over 4. I have a paper in degree. Yeah, I have another paper in radian. Maybe we use it better in radian. This is more elegant. I like that. However, let's do another paper in. Let me see. Whoa, this guy is good. Look. This is the in radians. Do you see?
Yeah.
Doesn't matter. We use in radian or degree. You know that. Entonces, what is the idea? We have a family of the circle, right? Yes or no? And the center is in the pole. And when you navigate in, o sea, this ordered pair is no the traditional que you are familiar x, y. No, no, no. Es r, theta. R represent radius and theta represent angle. Ajá, entonces let me try to explain. Radio 1 is the first circle. This one. 1, 2, 3, 4, 5, 6, 7, 8, 9, something, right? A1, and the angle is 5 pi over 4 is this angle, and the point approximately is this guy. Boom. Do you see that?
Yes.
Oh, beautiful. So you travel either way for the radio. The radio is the distance from the pole to the specific point you want to plot. And you rotate theta. Or either way, you rotate first and we moving for the... Okay, suppose another scenario. Look. Let me erase that part. Suppose another scenario. Suppose a second point. Que es the point in polar. We are talking about polar. 2,3 pi. Remember, this is R, this is theta. R2 is the second, no? The second circumference, R2. And 3 pi is pi. Because 3 pi is 1. 3 pi is 2 pi plus pi. And 2 pi is 1 revolution. So we are doing 1 revolution. I don't care. And stop in pi. Because the point is plotted like that. 2 and pi. Boom, here. Do you see or no?
Yes.
Okay. But this is a little bit complicated because to the XY plane, we have several possibilities to express the same point. Because we can use in theta like a positive or negative and radio like a positive or negative. And you see radio is negative, yes, radio is negative. Because in polar radio could be negative. Entonces, bueno, okay. Entonces, maybe the question can fly in the air. Professor, what is the reason I complicate my life using this new coordinate? Guys, you can see in calculus 2 and calculus 3, que, okay, or in calculus 1 also, yeah, a specific figure que have a specific shape like a circle, ellipse, something is better. My equation is better manipulating calculus in polar, no rectangle. Rectangle is crazy, so it's heavy mathematics. However, in polar is too easy. This is the idea. Suppose another point. Suppose 2 comma, same radio, but now I change the negative 2 pi over 3. It complicates your life. I put negative angle. When you have negative angle, I need to know that you go clockwise. The rotation is clockwise. Okay, by the way, this is equivalent to say 2 comma, like a 4 pi over 3. Yes or no? Because this is negative 240. So in degree is 240. And this is 240, no. Negative 120, sorry. This is negative 120 degrees. And this is positive 240. You see that they are coincidences, right? It's here. So 2 comma. Suppose, let me change the, record. It's 2 comma here, over there. Do you see the point? So this angle is negative 120 degrees, or equivalent radian negative 2 pi over 3, no? And the radius 2. Do you see or no?
Yes.
Okay. One more. Suppose the point. So today we plot the point only. After we study in detail the conversion. So what is the conversion between XY, rectangular to polar, and polar to rectangular? There are mathematical connection in between these ideas. But today the intuitive idea. How is the polar coordinate? Suppose 1 comma negative 3 pi over 4. Negative 3 pi over 4 is that one. And 1 here, I suppose 1, 1, 1, 1, 1 is in the first circumference. And 3 pi over 4 is equivalent to, say, 5 pi over 4. It's the same point here, right? Look, it's a coincidence. This is equivalent to, say, 1 comma 5 pi over 4, no? Okay, this is 135 degree, negative 135 degree. And this is 225 degree, no? Yeah. Okay. Okay, so the thing I try to explain is that there are no unique way to express the coordinate and polar, because we can using a positive angle or negative angle, and you see another example in which you're using negative radial and positive radial. Okay. Another example, another weird example. Let me show you another weird, and that's it. Okay, suppose it's given this rectangle, this polar, negative 3 comma pi over 4. How you plot that? Okay, my recommendation is always start for the theta, for the angle. Pi over 4 is 45 degree. Here, over there. So you rotate here. Ooh, bam. And 3. 1, 2, 3 is 1, 2, 3. Here, right? But this is positive 3. Si es negative 3 es en opposite direction. Entonces es here, 1, 2, 3. Here. This point is this one. Okay, the thing I try to explain is, when you have negative radial, you don't care. You navigate for the theta, que es pi over 4, 45 degree. Now you plot the point. 3 units, 1, 2, 3, and flip it. Bam! To the opposite direction. So we have different possibility. Radial positive, theta positive. Radial positive, theta negative. Radial negative, theta positive. Oh, both negative. It's crazy. Okay? One more and that's it. One more and that's it. Suppose. That point. Negative 4. Again, radial negative, comma. 5 pi over 6. Okay, 5 pi over 6 is 150 degree, no? It's positive. Entonces you rotate counterclockwise. 5 pi over 6 is here. Good, I like this. And negative 4, bueno, positive 4 is 1, 2, 3, 4. Pero when negative 4 is in opposite direction. Si es opposite direction is carajo, is here. No, it's 11 pi. Is 1, 2, 3, 4 over there. This is that point. Do you follow me? You understand or not?
So I just have a question. The theta means the revolutions?
No, the theta is the angle measured from the positive x-axis or polar axis. This is theta. Look, Noela, this is theta.
Okay.
Ooh, in this case is, in this case was 5 pi over 6. Do you see that?
Yes.
Entonces es negative 4. No in the positive direction. No in the negative direction. That is 1, 2, 3, 4. 1, 2, 3, 4. And this one. This point is this one. You don't worry for this. Because in Desmos, you switch in the plane to the polar. Do you want to show you now in Desmos?
Yes, Professor.
Let me see. I know that you have no time to practice now, but this is the problem that we are doing after the test, no? Okay, let me show you Desmos. Switching to Desmos. You see Desmos?
Yes.
Okay, so I want to create a new one. Okay, this is, let me see, save that, and create a new one. New one. Entonces now, you, for example, you go, let me try to remember. You go to this configuration, and you select polar. Boom, boom. Do you see that?
Yes.
And you, for example, select radian or degree, whatever you want. Let me use a radian because the problem that we're doing before is radian. A radian. Let me see. I have a paper here. Suppose I plot the stupid point. Parenthesis. -4. Comma. 5 pi over 6. 5 pi over 6. Boom. I plot that. 5 pi over 6. Something is weird. 5 pi over 6.
Yeah, because it's negative, right, Professor?
Yeah, I know. It's in another direction. No, let me use an elementary example, not complicated, because Desmos maybe gets confused. Suppose 2 positive, everything positive, comma, pi over 6. Boom. Look at that. But something is weird. I am sure, okay, select degree. Pi over 6 is that line. Okay, let me see. Again. A radian. Let me see the degree. Doesn't change. Suppose. Parenthesis. 2 comma 60. 16 or 30 degree. No, something is wrong. Something is wrong. Okay. No. Something is wrong. Okay, I have a script specifically for this. Pero no. Okay, do you think it's possible plot in Polar?
Yes, Professor.
Don't worry, because I create a script. I don't know exactly. I need to set up something. Okay, I don't do well. Okay, I don't know. See, pi over 6. Let me see, pi over 6 now. Pi over 6. No, it's pi over, no. A ver, no. It's like a 15 degree, no pi over. Something is wrong. Something is wrong. Okay, don't worry for this. Okay, guys. Time is over.
Okay.
So remember. The due date for the test, both tests, is this Thursday, okay? Okay, guys, bye-bye. Thank you.
So, Professor, are you going to be on the tutoring section tomorrow, right?
Yes.
Okay, thank you.